Okay, I'm going to go through the end of block assessment for place value. So number one, what number is represented below? So you look at how many 10,000s we have. We have one 10,000. We have 1, 2, 3, 4, 5, 6 thousands. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 hundreds. We have 1 10, and we have 1, 2, 3, 4, 5 ones. So the number is 16,915. Georgia says that the number is a multiple of 5. Is Georgia correct? Explain your answer. So yes, Georgia is correct. I apologise for my handwriting. And the reason she is correct is because any number that is a multiple of 5 always ends in 0 or 5. So it is enough for you to put the number ends in 5. And that means it will be a multiple of 5. It must be in the 5 times table. 2. So we're looking at breaking up this number here. We've already got the 40,000, so that's the first number here. Then we want the 7,000. The 600 is already there. No 10s and 3 ones is already there. So that's already broken up. Here, it's already broken up for you. You have to put the number all together. So we've got 50,000, no thousands, 300s, 7 10s, and 4 ones. So the number is 50,374. On the last one, it's a little bit trickier, so be careful. We've got the 80, so we've got 8 10,000s, so the 80,000's already there. Then we've got 7,000, but here we've only got, here we've got 8,000, so we need 1,000 more plus the 300. So we need 1,300. Number 3, in a game, people have some play money to buy houses. Each person starts with the following play money. How much money do they start with? So again, we just look how many 100,000s. I've just given the answer. There are 1, 2, 3, 4. There are 400,000s. How many 10,000s? 1, 2, 3, 4, 5. 5 10,000s, and then 1 2,000s. And we put the zeros in as placeholders to make sure that the number stays 452,000. Number 4, circle all the numbers that round to 4,750 to the nearest 10. So when we're rounding to the nearest 10, we always look at the ones column to help us make our decision. We can pretty much discount 748 because it's not going to round to 4,750 no matter what. There are no thousands in that number. So we're going to look at all the rest. I'm going to circle the first one because when I look at the ones column, the 2 is if it's less than 5, we leave it. So we leave the 10s column. So it's less than 5, 2 is less than 5. It means that we're going to leave the 10s as 5. So it's going to round to 4,750. I'll circle this one because again, when I look at the number, it's 5 or more means that we're going to round up. So at the moment, the tens column is 4. But because when we look at the ones, it's 5 or more, we're going to round that number up to 5, so it becomes 50, 4,750. The same with this one. We look at the ones, it's 5 or more. It means we're going to round the tens column up. So from 40, it's going to go up to 50, so it's going to round up to 4,750. We're not going to circle the last one because, again, if we look at the ones column, it's 5 or more, which means we're going to round up the tens column, and so that's going to round up to 4,760, and we don't want that. Number 5, we're chunking up the number again, so it's 305,700. We've got the 300,000. There are no thousands, so no 10,000s, but there are 5,000s, and we have the 700 already there. Okay, and the next one, which is the greater number? Explain your answer. So you've been learning Roman numerals with Miss Debbie in calculations. So hopefully you should know this, that X stands for 10, C stands for 100. But then, so this one should be fairly straightforward. We've got 110. Okay, so CX, then we've got the 100 and we've got the 10, 110. This one's a little bit trickier. We've got letters before each of the C and the X. So if we look at the C here, before it is an X, and so that means we subtract. So 100 take away 10 gives us 90. Same here with the X. You've got 10. Before it, we've got I, which stands for 1. So 10 take away 1 gives you 9. So this represents 99. So this is the greater number. And when it says explain your answer, it is enough for you to write down that this in Roman numerals represents 99 and this one represents 110 in Roman numerals, and that is enough for you to explain your answer. You don't need to put down about the subtraction. I was just saying that to explain to you. Okay, what numbers are represented by the arrows? So first of all, we see how much it's split up into. So we've got from 50,000 to 60,000, and it's split up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's split up into 10, so that I'm assuming then that if we split 10,000 up equally into 10, each one is 1,000. So we can say that this one here is 51,000. This one here must be 52,000, 53,000, 54,000, 55,000, 56,000. So I'm just going to put my answer in, 56,000, and I'll keep going. 57,000, 58,000, 59,000, and then finally 60,000. Okay, so you just see how much you need to split it up into. Here we've got from 500,000 to 600,000. So that's a gap of 100,000. And it's split up again by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a gap, so into gaps of 10. So 100,000 split up equally between 10 is 10,000. So we're adding on 10,000 each time now. So it's a 10,000 column that we're looking at. So 510,000 would be this one. This one would be 520,000. 530,000, 540,000, 550,000, 560,000. Oops, sorry. 570,000, 580,000, 590,000, and then finally 600,000, each time adding 10,000 more on. Okay, here we need to put in our less than, more than, or equals symbol. Okay, so remember that the mouth of your inequality symbol always faces the bigger number. Okay, as I explained in class, the hungry crocodile always wants to eat the bigger number. It wouldn't be interested in the smaller one. So here, 12,900 is greater than 2,980, because when you look at the place value, it's got 10,000, 10,000, 2,000s, 900s, no tens, no ones. This one, so when we look at this number, it already we can see that it's smaller because it has no 10,000s. Here, looking at the place value, we can see that it's got 5 10,000s and 7 1,000s. But here, we can already see that it's got 5 100,000s. So that number is bigger. Again, we look here, we've got 999,999, 1 million. And again, we don't have to write the number out, but we can see straight away that we've got a 1 in the million column, whereas here we start from we've got 900,000, so nothing in the millions column, so 1 million is bigger. Okay, number 9. Arrange your digit cards to make an odd number between 70,000 and 100,000. Okay, you need to remember that an odd number is a number that ends in 1, 3, 5, 7, or 9. Okay, so I can use the digit cards 1 and 9 to end my number, but I need to be careful that my number needs to be between 70,000 and 100,000. So I can't put 1 first of all, because that would make the number less than 70,000. So I'm actually going to put 9 as my first number, and then I can put the numbers in any order I like. So I'm going to put 9 as my first number, cross it out to make sure I've used it, and then I'm just going to put the numbers in any order as long as I end with the 1, so to make it odd. So 98,641, and that would be between 70,000 and 100,000. You could have put the 8, the 6 and the 4 in any other order. So some of the other ones you could have had would be 96,841. You could have had 94,681. Yeah, and there are other ones that you could have, but that's just some of the others. Okay, so then I want to round this number to the nearest thousand. So you look at the place values, so place value before. So I look at the hundreds. If it's 5 or more, I'm going to round my thousands column up. In this case, it is 5 or more. So I'm going to round it up from 8,000 to 9,000 and then put zeros in to as placeholders to hold the value. Now I'm going to round to the nearest 10,000. So this time I need to look at my thousands column, which is here. It's 8. It's 8, so it's 5 or more, so I need to round my 10,000 up from 9 to 10, and then I put zeros in to hold the value, so it becomes 100,000. If you had chosen 96,841 to the nearest thousand, it would be 97,000, and then to the nearest 10,000, you would again round up to 100,000. And then if you had put that as your number, to the nearest thousand, it would be 95,000, and then to the nearest 10,000, it would be 90,000. But please ask me if you are unsure or you have chosen a different number. Right, number 10. Fill in the missing numbers. So you've got 19, then 10,019, and then, so there's a gap here, and it jumps to 30,019. So we can see that what's staying the same is the 19, but the 10,000 column keeps changing. It's 10,000 here, so it's going to be 20,000 here. It's 30,000 here. It's going to be 40,019 here, and then finally 50,019 here. So the 19 stays the same in all of them. It's a 10,000 column that keeps changing. Number 11, put the following weights in order, starting with the smallest. So here, first of all, I'm just going to tidy this up a little bit. So you've got 94,000, so we're going to write it out so that you can see what that is. So that's 94,000, got 700,000, 87,000, and then 399,458. So let's have a look at our columns. So first of all, let's start with the hundred thousands column. Here we've got 700,000s. We've got 0 hundred thousands here, 0 hundred thousands here, and 300,000 here. So it could be either between these two, because they've both got 0 hundred thousands. So remember, we're starting with the smallest. So they have 0 hundred thousands. So either of those could be the smallest. So now we need to look at the 10,000s column. This has got 9 10,000s. This has got 8 10,000s. So 8 10,000s is the smallest. Then it would be the 9 10,000s. So C would be the second smallest. Now we need to decide out of 700,000 and 399,458 to see which one is the next smallest. So again, we look at the 100,000s. There's 3 here, and that has 700,000, so it must be the biggest. Okay, last question. The thermometer shows the temperature in London in May. In January, the temperature was 20 degrees colder. What was the temperature in London in January? Okay, first of all, you have to read off the scale here. You can see it's going up as we go this way. So 14 jumping up into 16, but it's halfway between 16 and 18. So it must be 17 degrees here. So in May, it's 17 degrees. In January, the temperature was 20 degrees colder. So we're going to do 17, take away the 20, and that's going to end up being -3. So -3 degrees. So that some of the negative numbers work that we kind of touched on before, but that bit is quite challenging, and I would suggest using a number line in order to help you with that.